Hi there. Today we're going to be talking about graphing quadratic functions. In our last class period, we were working on solving quadratics, and today we're going to take that skill and we're going to move forward with graphing of the quadratic functions. In the same way that we were able to solve a linear function, then we could graph a line, we are now able to solve a quadratic and graph a quadratic. So for starters here, we see that a quadratic function is just a function that can be described by an equation of the form, and here's just standard form. When we talked about standard form last time, ax squared plus bx plus c equals 0. Remember, it needs to be set equal to 0 before you can start solving it. When we graph our quadratic, it's going to be in the shape of a parabola. And that's that new word right there for us, parabola. When you graph a quadratic, that shape of a parabola actually takes the shape of a U, right? Now, a parabola has some different parts to it that we're going to be learning about today. One of the parts of a parabola is a vertex, and the vertex can be described as being a maximum or a minimum. So the vertex, by definition, is the max or the min of the parabola, okay, and it's a specific point. So if we have, let's say, let's do a little mini over here, and I make a parabola. This is a parabola shape, okay, and the high point of that parabola would be right there. That would be the vertex of that parabola. In this case, it's at the top of the parabola, and that parabola is pointing down, so that would be a max. And when we look at standard form, ax squared plus bx plus c, that a term, if a is less than 0 or if a is negative, then you're going to have a maximum. If we draw another little mini, and I can make it so it's opening upwards, there's another parabola. You see this is opening downwards, and this one is opening upwards. This would be the vertex, except in this case it's at the very bottom of that parabola. It's at the low point, so that would be a minimum. And the same way we could take A and make that decision about a max and min, I can take the A and describe the minimum here. So if A is greater than 0 or if A is positive, then it will be a minimum value. Another part of graphing a quadratic function is what we're going to call the axis of symmetry. And if you recall, a line of symmetry will divide a figure into two symmetrical parts, kind of like a mirror, right? It'll create a reflection on either side of that axis of symmetry. So we're going to have another formula here. It looks like a piece of our quadratic. We have that negative b piece, and we have the over 2a. And we're just going to take that one part right there and use it to find the axis of symmetry, all right? And that we'll see in a moment is going to be where we start building our parabola. So let's go ahead and jump on in. We're going to take our first function here, y equals x squared minus 4x plus 5. And as we get started here, we want to go ahead and identify our a, b, and our c. So we can say that a is going to be 1 because the coefficient of that x squared is 1. B equals negative 4. And c equals 5. So I can start right there, and since I'm looking for the axis of symmetry, that's the first thing I need, I'm going to start with our new formula. X equals negative b over 2a. And just like we did with our quadratic formula last class, anytime we do a substitution, we want to make sure we put that into parentheses so that we don't lose or drop any negatives. So we'll have negative b, so that's negative negative 4 over 2a, or 2 times 1. That negative negative 4 is going to be a positive 4 over 2, and that simplifies to 2. Now, be mindful that this isn't just a 2, it's x equals 2. So since it's an axis of symmetry, that tells me it's going to be a line. And I know from earlier lessons that x equals 2 is actually the equation of a vertical line. So on my graph, I'm going to go to 2 on my graph on the x-axis, and I'm going to draw a vertical line at 2. I'm going to make that a dotted line. I'll go ahead and put that on there. There's our graph. I'm going to label it just so that we get comfortable with all the different parts. That's our axis of symmetry. All right. So when I graph my parabola, what I have on one side of the parabola should be a reflection of what's on the other side. So it should be a mirror image on either side there. Okay. Now I'm going to go ahead and find the coordinates of the vertex. Okay. That maximum or minimum point. That's going to be our next step. And we're going to follow these same steps each time. We're first always going to find the axis of symmetry. And we're always going to find the vertex because you have to start from the ground up to build your parabola. So we're going to start by taking that x equals 2. And we're going to use that to start building our vertex. I can see just intuitively that the vertex is going to be on that axis of symmetry, because just think, if the axis of symmetry cuts that parabola in half, well, that vertex is going to be on that axis of symmetry. So if I already know that x equals 2, then I can take my original equation here, y equals x squared minus 4x plus 5, and I can substitute in that value of 2 into my equation to find the y value, and that'll give me an ordered pair to plot on my graph. So I'm going to go ahead and substitute 2 squared minus 4 times 2 plus 5. So we'll have 4 minus 8 plus 5 there, so that we have y equals 1. So my x value that I plugged in was 2, and now my y value is 1. And again, I got that 2 from before, okay, from solving up here. So I can take that ordered pair 2, 1, and I can come over here to my graph to 2 on the x, 1 on the y, and plot that point right there. I'm going to label the point 2, 1, and that is my vertex. So now that I have the vertex, I can describe it as a maximum or a minimum. Well, if a is equal to 1, well, 1 is greater than 0, and in my note up here, I said that if 1 is greater than 0, if a is greater than 0, then that's going to be a minimum. So this graph is going to have a minimum, okay? So when I'm looking here, that means I can kind of predict what's going to happen with the shape of the graph. If that's the minimum, I know there's going to be opening upwards, and my graph should have a shape like a U, a right side up U, okay? All right, our next step is to find the x and the y-intercepts, all right? So again, I know from graphing lines that if I'm going to find the x-intercept, where that line is crossing the x-axis, that I want to go ahead and make y equal to 0. To find the x-intercept, I'm going to set y equal to 0. So in that case, if I go back to my original equation, that means I'm going to have 0 equals x squared minus 4x plus 5. Okay? So from there, I can see, well, I need to solve that for x, and I've learned 2 ways that I can do that. I can either do that by factoring, or I can use the quadratic formula. Those are the 2 ways I can go about solving here, solving this quadratic. So, I mean, I can do some mental math and to see if I can factor it, because, you know, factoring is a pretty simple thing. So I can say, well, 1 times 5 is 5, so I'm looking for factors of 5. that those factors have a sum of -4. And if I run through the possibilities in my mind, I'll quickly see that I can't factor this. So that means I'm going to have to go with the quadratic formula, and we'll take our -b plus or minus square root of b squared minus 4ac all over 2a. And feel free to look back at your notes from last class to get that formula. But if we just go ahead and plug in our values, our a, b, and c that we pulled out earlier, because again we're using the same equation up here, I'll have -4 plus or minus -4 squared minus 4 times a times c all over 2a. And that's going to simplify to 4 plus or minus root -4 over 2. And if you recall from last class, we talked about having that negative root, and that if you had a negative under your radical, that was an indication there was no real solution. There's a solution, it's just not a real solution. No real solution. That type of response will be an indication to you that there is not an x-intercept, that there is no x-intercept there. And if I look back at the beginning of my graph, that really makes sense, because if the x-intercept is where I cross my x-axis, and I know this graph is opening upwards, I can see that it's not going to cross the x-axis. The whole parabola is sitting above the x-axis. So that makes logical sense there. All right, so let's go ahead, since there is no x-intercept, let's go ahead and look for the y-intercept. Just like we were able to set y equal to 0 for x-intercept, now to find the y-intercept, we're going to set x equals to 0. And we're going to go back to that original formula again. You're going to keep going back and using that same formula over and over again. So we have y equals 0 squared minus 4 times 0 plus 5, and that's just going to be 0 and 0, so we just end up with y equals 5. Now again, that's going to give us an ordered pair where our x is 0 and our y is 5. So we can come on over to our graph and put 0, 5, and that's going to be our y-intercept. Right? So far I have a couple of points there. I have 2 points. Okay? And what I need, though, to make a really nice parabola is I need 5 points. I need 5 points for every graph. And we're going to use that idea of symmetry to be able to get some additional points. So remember, with symmetry, this parabola is going to be a reflection. So however many points, whatever the distance is from this first point to the y-axis, because this is an axis of symmetry, I know that there should be an identical point, 2 points on the other side. So if I go 1, 2 points here, I should be able to go 1, 2 points away and get its reflection. And that point is going to be 4, 5. So now I have a nice grouping of 3, but I need one more. And the way I can do that is I can make a table. Now you can do your equations in tables. I think it's tidy. It makes it nice and organized on your paper. Or you can solve them out separately. You know, it's up to you what you want to do there. So I have 4x, again my same equation, there it is, y, and then we'll have our ordered pair over here. So that way you only have to write the equation one time and you can just keep plugging into your table. I could have taken this over here and I could have put a 0 in my table and I could have solved it that way right on the table and had it nice and tidy right here like that. I could have started a table instead of doing it as an equation. It's a preference. So then how do you choose another point for your table? What am I going to do? Well, I know that as I move upwards that the graph is going to extend outwards. It's going to keep kind of moving out from that axis. So if my first point I have here is 0, then the next nice point would be to go out 1, so -1, right? So I can take -1 for x, and I can just plug that -1 into my equation, and that's going to give me a +10. So that gives me an ordered pair of -1, +10. I could just have easily picked +1. That would have given me somewhere in between these 2 points, and that would have been just fine also. So we have -1, +10. There's that point, -1, +10. And again, I'm going to use the idea of symmetry. Instead of plugging another point into that table and having to solve another equation, I can just say, well, I'm 1, 2, 3 points away from my axis of symmetry, so the reflection would be 1, 2, 3 points away from my axis of symmetry, and that would lie at 5, 10. So let's make ourselves just a little note, a little reminder note here, that to get extra points, to get those 5 points, we can reflect our points over the axis of symmetry. And a thing you need to remember when you do that, it's been a while since you guys have had to do reflections. Remember that the original point and its reflection, so the point and its reflection, are the same distance, the same number of units, are the same distance from the axis of symmetry. So they're the same distance. So this one is 1, 2, and this point up here is 1, 2. So it's the same distance from the axis of symmetry. Likewise up here is 1, 2, 3, 1, 2, 3. So they're equidistant from that line. So now we have our 5 points. Now we can turn this into a parabola. And we're going to do that by connecting the dots. But make sure you don't connect it as a V. It shouldn't be a V. It should be a rounded edge down here. And I always do it gently with a pencil just so I can get a nice shape out of it. I can never seem to just draw a nice line, so I always like to take my time a little bit, making a nice shape of a parabola. All right, so there's our first one. It'll get easier after this one. So let's go ahead and just jump on down. I am going to pick up the pace a little bit, so if you need to pause, that's a good idea. If you need to rewind, that's a good idea as well. So we're just going to start with our next equation. All right, we'll see it looks similar, but instead of a +5 here, we have a -5, and that's going to make a big difference. And I just kind of want you to think about when you look before and after what that difference was. It's kind of interesting how it all works out. So again, our first step is to identify our A, B, and C. So A is 1, B is -4, and C is -5. The first thing we need to find is our axis of symmetry, and you'll notice on all your notes, on your homework, on your quiz, you're always going to have this list to find right here, and if you just go through like a checklist, it shouldn't be a problem at all. So the first thing we want to find is our axis of symmetry. I'm just going to abbreviate that, and you can as well. I'm going to start with my formula, x equals -b over 2a. I'm going to plug my values in there, -4 over 2 times 1 gives me, again, same thing here, gives me 2. Remember that that's the equation of a line, that it's x is equal to 2. So x is equal to 2. And again, I want to, let's move that camera down so we can see that a little bit better. There we are. We want to take our ruler, and at 2, we want to draw that axis of symmetry, which will be a dashed line. There we go. And I'm going to label that x equals 2. That's my axis of symmetry. And that takes care of that. So we're off to a good start there. Trying to get everything centered here. I move too much when I write. There we go. I think that should do. All right. Next thing we're going to do on our list is that vertex. So we're going to go with our vertex next. Remember, that's our maximum or our minimum point on our parabola once it gets open. And since I already have the value for x, I can take that x and plug it into my original equation here. So I'll have y equals 2 squared minus 4 times 2 minus 5. It'll give me 4 minus 8 minus 5, which will give me y equals negative 9. So our vertex, x is 2, so that's another ordered pair, 2, negative 9. 2, negative 9. So I can come over here and I can say, I can go 2 on my axis of symmetry, and then, or 2 on my x-axis, and I'm going to go down to negative 9, and that puts my vertex on my axis of symmetry. I'm going to label that as well. Now you need to decide if that's a minimum or a maximum. Well, if I look at my a value is 1, and 1 is greater than 0, and if it's greater than 0 or it's a positive number, then I know that will be a minimum value. Next step is to find our x-intercept. So I'm looking for my x-intercept here. That means I'm going to set y equal to 0. So I can say 0 equals x squared minus 4x minus 5. And I can start a little table to see if it will work out. I'm looking for 1 times negative 5 is negative 5. And I'm looking for a sum of those values to be negative 4. So if I take factors of negative 5, I can say, well, negative 5 times 1 is negative 5. And negative 5 plus 1 gives me negative 4. So that pairing will work out nicely. So then I can just go ahead and factor by grouping. I can rewrite x squared minus 5x plus x minus 5. I can put those into nice groups. Go ahead and group those guys together. In my first group, I can factor out an x, and I'm left with x minus 5. I know my second group also has to be x minus 5, which means I'm factoring out a positive 1. So I'll have x plus 1, x minus 5 here, and that'll be equal to 0. And that's where we really had our last lesson, was on how to solve those. And remember, we can break that into two separate mini equations, x plus 1 equals 0, and x minus 5 equals 0, so that x equals negative 1, and x equals a positive 5. Now that's going to give us 2 points, so we'll have 2 ordered pairs here. X is negative 1, where y was 0, and x is 5, where y is 0. So our x-intercepts, negative 1, 0, and 5, 0. And I can go ahead and plot those 2 points. So negative 1, 0 will be here, and 5, 0 will be here. And one way to check that everything is going according to plan is that those points are equidistant. So I can just count 1, 2, 3, 1, 2, 3, because remember that's an axis of symmetry. So that's just a good little checkpoint along the way to make sure that you're on the right track. Last but not least, we need to find the y-intercept. Remember, with the y-intercept, we're looking for x to be equal to 0. So I can say y equals 0 squared minus 4 times 0 minus 5. And again, we're just going to keep going back to that original equation every single time. We used the original equation here, we used it here, we're using it down here again. So if you ever get stuck or you get lost, just go back to the beginning, go back to your original equation. And so y here is going to be negative 5, And that's going to give me that ordered pair where if x is 0, then y is -5. So my y-intercept will be 0, -5. So I can go ahead and graph that, 0, -5. And that gives me 4 points, and I need 5 points to make a nice parabola. So I can go ahead and use my axis of symmetry and make a reflection of this point, 1, 2 to the axis, so 1, 2 away from the axis, and that point is for -5. So I've got my nice 5 points there. Now I can go ahead and connect the dots. Remember, we want a nice rounded bottom there of that parabola. It's not the letter V, it's the letter U of some sort. Make sure that you sketch your graphs all the way up, just like we didn't like short little stubby lines. We don't want short stubby little parabolas. Make sure it extends the length of your graph. So here we can see everything we talked about. We see that the vertex is indeed a minimum. That's at the very bottom because it's opening upwards, right? It's opening up there. We have our 2 intercepts here, our 2 x-intercepts, and that matches up with the 2 points that we got because it's crossing in 2 different places. And we have our 1 y-intercept there. Nice. Let's go ahead and turn over and let's look at the back. Got some more practice to do here. Right, now this one kind of goes from a different perspective. This one, we're not trying to make the graph. We're going to look at the graph and analyze it and pull the information off of the graph. So this is kind of like vocabulary matching here. So our axis of symmetry, I see that line is right here, okay? And it's on 1, right? So this line here is going to be x equals 1, and that is my axis of symmetry. I like everything to be labeled. It helps as you're learning. The more you write something the first time you learn it, the better off you are to remember it there. When I'm looking at my picture here, I'm looking for a vertex, and I know the vertex is the high point, and I see this point right here is the high point of that graph. And that point is at 1, 0, and that is the vertex. So that's going to be 1, 0. And just looking at it, it's at the top, so that means it's a max. And I can check that with what I know. If I look at the coefficient here of my first term, my A term, it's -1. Well, -1 is less than 0. And from the other side of our notes, we saw that if it was less than 0 or a negative number, then that would make it a maximum, and that's exactly what we have happening here. And I also know that it's a max, because in this case the maximum shows that it opens down. The other 2 parabolas we had were opening up, and this one opens down. Alright, I also have a y-intercept where it's crossing that, or the x-intercept where it's crossing the x-axis, and there's that point. It's actually sharing a name there. So we're going to have that same point, 1, 0. And finally, where am I crossing the y-axis? Our y-intercept is this point, oh, wrong color, is this point, there we go, this point right here. That's our y-intercept, and that's at 0, -1, okay? So you should be able to really look at these graphs going in both directions, either being able to start from scratch and build the graph and make the graph and find all that information, or just look at a graph that they give you and be able to pull all that information off just by looking at the picture. All right, let's go ahead and move on down to the next one. I'll zoom in here because we're going to have some work to do on this one, I think. All right. Let's go ahead and highlight our next problem so it jumps out at us. It's always nice when they jump out at us. And first step, just like before, is to start with our axis of symmetry. But before we do that, we need to take out our A, B, and C points. So here I have A is -2, B is equal to 8, and C is equal to -1. So if I start with my axis of symmetry, I'm just going to keep everything labeled and organized so we know what work belongs to which piece. Don't forget we have that new formula, x equals negative b over 2a. And again, I can just substitute. That's going to be negative b over 2 times a. So that's going to be negative 8 over negative 4, which again gives us a positive 2. And I do just want to say that the axis of symmetry is not always 2. It seems like everything we've done has been 2. That one just before us was at 1, so that was nice to have something a little bit different there. So here we are, x equals 2. So again, we'll take our rulers. We want a nice straight line. We don't want to hand draw those because it's not possible to draw a nice straight line without a ruler. We'll make sure we do a nice job there. So we are again at x equals 2. So from there we want to go ahead and find our vertex. So we'll find our vertex and we're just going to use the points that we have, that x equals 2, we're going to plug that in. But what I'd like for you to do at home is I'd like for you to go ahead and just pause the video and find the vertex by yourself and then push play again and then check your work against my work to make sure that you're on the right track and that you're able to do this by yourself. So go ahead and pause it and then come back in just a moment. Now that you're back, let's see, we're going to have y equals negative 2. What do I have? Negative 2 times 2 squared, because or negative 2x squared, and our x was 2, so that is 2 squared, plus 8 times 2 minus 1. So 2 squared is 4 times negative 2, that's our negative 8, plus 16 minus 1. So we're going to have y equals 7 here. So that means our vertex is going to be at 2, 7, because the x was 2 that we plugged in, and our y value turned out to be 7. So if I come to positive 2, positive 7, I can label that point, and that is my vertex. Now I can look at my a value. A is negative 2, and negative 2 is less than 0. If you recall from the front of your notes, if it's less than 0 or if it's a negative number, that means we're going to have a maximum value there. So that means when I look at my graph, it's going to be opening downward. It's going to have that shape right there, because that'll be the high point of our graph. Next step, X-intercept. X-intercept. Remember, when we're looking for x-intercept, we're going to set y equal to 0. So in this case, I'll have 0 equals negative 2x squared plus 8x minus 1. If I quickly just check in my head if I can factor it, negative 2 times negative 1 is positive 2. And there's no combination of factors of 2 that is going to give me a sum with 8, which means I have to use the quadratic formula. So I'm going to have x equals negative b, so that's negative 8, plus or minus root b squared, so that's 8 squared, minus 4 times a times c, all over 2a, so 2 times negative 2. Go ahead and take a moment. You can pause me again, use your calculator if you need to simplify that expression, and then come back to me. So we should have gotten here negative 8 plus or minus root 56 over negative 4. Now, I know that root 56, that's not a perfect square, and it can't be simplified here. So what I'm going to need to do to be able to graph it is I'm going to have to estimate the value so that I can plug it into my graph to get a value here. So remember that the plus minus I can break into two pieces. I can have x equals negative 8 plus root 56 over negative 4, and x equals negative 8 minus root 56 over negative 4. And remember on your calculators to use your parentheses properly so that you can simplify this and round it to a decimal. When you plug that into your calculator, you should get x equals 1300. We're going to round to the nearest hundredth place. I'm going to show you again on the calculator how to do that in case you have forgotten. So you can have your negative 8, make sure you're using your negative button and not your minus button, plus second root 56, and it might be easiest to just push enter then and then divide by negative 4. And you'll see that we're going to get a very long decimal there. So we're going to round to the hundredths place. And if you're trying to do it in one step, just remember you have to use your parentheses to remind your calculator of the order of operations that you want to follow. That piece right there is your numerator, and then you can divide it by a negative 4, and you'll get the same result. If you're having trouble with your parentheses, go ahead and do it in 2 separate steps. And that'll also work when you go to do your subtraction here. When you do your subtraction, you should round to the nearest hundredth again, and you should get 3.87. So that's going to help us to estimate. Remember, those are estimates right there because we had to round them. Our piece here with the radical, that's our precise exact answer, but that's difficult to place onto a graph. So we're going to just use our calculators to estimate the points for a graph. Just make yourself a note that that's what we're doing so that when you look back later, you're not looking at it going, where did that number come from and why did I do that? All right, so now those are our x values. So my ordered pairs here would be 1300ths, and our y value was 0. So then we have 3.87 and 0. So when I go to graph that 1300ths, that's going to be just barely past 0. So that would be barely past 0. And with the pen, you know, it's actually looking a little further away than that because that's hardly anything. So let's go ahead and label that point. Okay. And then on the other side, 3.87 is going to be just a little bit less than 4. Almost 4. Not quite. And 0 there. So there's our 3 points that we have. Let's go ahead and find our y-intercept now and finish this graph up. So now I find y-intercept. Remember, with our y-intercept, we're going to set x equal to 0 so that I have y equals negative 2 times 0 squared plus 8 times 0 minus 1. And that's 0, so y equals negative 1. So my ordered pair here is 0, negative 1. So I can come over here and plot. I can say 0, negative 1. I can see already where that graph is going to come just perfectly right there. 0, negative 1. And I need a fifth point, so I can say, use my reflection. That's 1, 2 from the axis of symmetry. So 1, 2 from my axis of symmetry here. And I'm at 4, negative 1. And I can see how nicely that's going to turn out. It's going to be just perfect there. So it's going to be a skinnier graph. Make sure it has a rounded edge there at the top. And I just kind of follow it down. All right. And the skinnier the graph, the skinnier the graph, the points are really narrow. You can have really wide parabolas, really narrow parabolas, and we'll be looking at some of those patterns in our next class. All right, one more to go. What I'd like for you to do is try to do this one start to finish by yourself without me. Go ahead and pause. And what I would recommend is to do each step. So like try axis of symmetry and then check yourself, and then move on to the vertex, pause it again, work on it by yourself, come back and watch me and check yourself so that you can correct your work as you go if you need to, or just pat yourself on the back as you go because you're doing such a great job. So go ahead and push pause and give it a try, and push play as you need to check your graph there at the end. One thing I want to caution you against is to look at this interval that we've got here. We're not counting by ones, we're counting by twos each time. So keep that in mind when you go to graph. So for starters, we want to pull off our A, B, and our C so that A is 5, B is -10, and C is -15. First thing I need to find is my axis of symmetry. Always our first step. I'm going to take our formula here, x equals -b over 2a. Plug in those values, -10. Don't forget your parentheses so you don't lose a negative in the mix there. And then 2 times a, or 2 times 5, is going to be 10 over 10 for a positive 1. So again, that's x equals 1. So my axis of symmetry will be at 1. Now again, this point here is 2, so I want to try and get that halfway. You have to be patient with yourself, trying to get everything lined up nicely, and just do the best you can. When things are tight like that and the grids are small, sometimes it's hard to get things exactly, but slow down, be precise. Get it as close as you can with your ruler, and that's x equals 1. Now I want to move on and find my vertex. To find that vertex, I'm going to take that x value that I just found and plug that back into my original equation. So 5 times 1 squared minus 10 times 1 minus 15. Watch your order of operations. 1 squared is 1 times 5 is 5 minus 10 minus 15. This can give me a -20. So my vertex is at 1, -20. And if I look at my a value, a is 5. That's a positive number. 5 is greater than 0. That means that's going to be a minimum. Next, I want to find my x-intercept. I'm going to do that by setting y equal to 0. So I have 0 equals 5x squared minus 10x minus 15. When I'm looking at that to factor, I see right away that I have a GCF, so I can go ahead and factor out my 5. That leaves me x squared minus 2x minus 3. If I just run quickly through my mind, 1 times -3 is -3. I'm pretty sure I can get factors there that give me -2. If I have -3 for my product, I'm looking for a sum of -2. Well, if I say -3 times 1, that gives me -3. When I -3 plus 1, that gives me -2. So that should work out nicely. So I'm going to have 5 times x squared minus 3x plus x minus 3. And I can group those nicely. Here I can factor out an x from my first group. I know I need to have a matching pair. To get from here to here, I know that I just factored out a positive 1. So that's going to give me 5 times x plus 1 times x minus 3. And all of that is equal to 0. So if you think these are my 3 factors, I can break it apart and set each one equal to 0. Except 5 does not equal 0, so that's not true, so we don't even have to worry about that one. Here, x plus 1 equals 0. That comes out to x equals -1, and here x equals +3. So again, I have 2 points. That's -1 and 0 and 3 and 0. So those are going to be my x-intercepts, the 2 points where this graph is crossing that x-axis. So if this is 0 and this is -2, well, -1, 0 would be there. -1, 0. And 3, 0, well, that's 2 and 4, so 3 is halfway. And there's 3, 0. So there's my x-intercepts. Last but not least, I can find my y-intercept. And to do so, I'm going to say x is equal to 0. So y equals 5 times 0 squared minus 10 times 0 minus 15. So that'll be 0, 0. So y is just going to end up being -15. So my y-intercept ends up being 0, -15. And I can graph that. 0, 12, 14, 16. There's -15 halfway between. And that gives me 4 points. Oh, I never put my vertex on the graph. I wrote it down, but I never drew it. So let's go ahead and draw that real quick so we have 4 points, because I see 3. We said our vertex was at 1, -20. There it is, way down there. There it is, 1, -20, and that's our vertex. All right, almost done. We need 1 more point. So we can take that last point we did, that 0, -15, and we can make the reflection. Well, remember that that's at 1, so 0 to 1 is 1 point, so 1 to 2, right on that other side there, is our other point. So it's going to be 2, -15 for that reflection. And finally, we can connect the dots, and this is going to be a really skinny, this is a skinny, skinny graph. Skinny, skinny parabola. There it goes, all the way up. Remember to extend your lines all the way up. And there we go. All right, so that is graphing quadratic functions. All right, so you have your homework, so you can practice. There are 5 for you to solve and 1 for you to analyze, like we did up at the top of this back page. Just take your time, refer back to your notes, and if you have questions, please bring them to class.